Before you do lesson 24, make sure you do test D in the test masters on reducing fractions. And lesson 24 is about reducing fractions. You first had a lesson on reducing fractions in lesson 15, and in that lesson you learned that you could divide the numerator and denominator by the same quantity, which was the greatest common factor, and that would reduce the fraction to the lowest possible terms or numbers that it could have. Now in this second lesson on reducing fractions, we're going to apply what we learned in lesson 21 to this lesson, and we'll have a little bit bigger fractions that we're working with, and we'll use prime factorization to figure out how to reduce the fractions. Let's learn about reducing fractions by doing some practice problems. And look at practice problem A. I want you to reduce 36 over 108 to its simplest terms, or lowest terms. A big fraction like that, the best thing to do is to use prime factorization first. Now you could do it like we did in lesson 15, where you find the greatest common factor, but these are just pretty big numbers, so it's harder to find the greatest common factor. Just take 36 and 108, just kind of do them separately and do the prime factorization of each one. So 36, let's just do a factor tree on that, and we could have 9 and 4, and then we'd end up with 3 and 3 and 2 and 2. So that's the prime factorization of that. So let's write it up here next to 36. 2 times 2 times 3 times 3. Now let's do 108. And I can't think of anything right off the top of my head for 108. So let's just do division on that one. Let's use divisibility. And, well, we can add those up. 1 plus 0 plus 8 is 9, so we know that 3 is going to be a factor. And so let's do that. 3 goes into 10 3 times. Left with 18. 3 goes into 6, or 3 goes into 18 exactly 6 times. And therefore we're left with 36, which is just what we have over to the right. 2 times 2 times 3 times 3. So we'll have 2 times 2 times 3 times 3 times 3. Now here's the neat thing that you can do when you have factors in the numerator and denominator that are the same. You can just cancel those out because that relationship equals 1. Like you have a 2 over 2 there, a 2 over 2, a 3 over 3, another 3 over 3, and so we have enough factors, or the same number of factors on top as on bottom. Let's just put a 1 here because a 1 won't change anything. And basically what we're saying then is 1 times 1 times 1 times 1 times 1 over 3, which equals 1/3. That would be the reduced form of 36 over 108. So we used prime factorization to figure that out. Let's do another one. Let's use prime factorization to reduce 72 over 400 to its lowest terms. And let's start with the 72. We can do a factor tree on that. We'll just do it over here to the right. And 9 times 8 is 72. And we can stop there because you can kind of see that 9 would be 3 times 3, 8 would be 2 times 2 times 2. So let's just go ahead and write that over here. 2 times 2 times 2 times 3 times 3. Okay, and then we have 400, and we could break that into 40 and 10. 10 would break into 5 and 2. 40 we could break into 8 and 5. And we can stop there because we know 8 would end up being 2 times 2 times 2. And we'll have 2 times 2 times 2 times the 2 from the 5 times 2 times 5 times 5. Now let's look at all of our common fractions, or fractions that equal 1 basically. Not common fractions, but fractions that would equal 1. We have a 2 over 2, another one, another one, and then that's it. So all of those would equal 1, so we don't worry about those. We just look at the 3 times 3 over the 2 times 5 times 5, and we end up with 9 over 50. So let's just write that down right here. 9 over 2 times 5 would be 9 over 50, and that's the smallest that we can reduce that fraction into. That's its lowest terms, 9/50ths. It's also called simplifying a fraction. We can't simplify 72 over 400 any more than 9 over 50. Now think about something else here. All of these values, when we do these ratios and they equal 1, 2 over 2, 2 over 2, 2 over 2, let's go horizontally and look at practice problem A. And what I mean is just circle all of those factors, circle all of those, and that's your greatest common factor. Like for practice problem A, it's 4 times 9 or 36. 36 is the greatest common factor for 36 over 108. And then look at B. You have 2 times 2 times 2 over 2 times 2 times 2. 8 is the greatest common factor for those two problems. 8 times 9 is 72. 8 times 50. So in reality, what you're doing when you do prime factorization and you see what you can cancel because the numerator and denominator are the same, you're really canceling out the greatest common factor. It's just in its prime factored form. Why am I telling you this? Because you can take any two numbers, no matter how small or how big they are, do the prime factorization of each one of them, and you can quickly determine what the greatest common factor for those two numbers or two or more numbers is. Let's do a problem. Let's find the greatest common factor between those two numbers, 84 and 360. So all you do is prime factor each one of those, do prime factorization on each number, and then all the factors that they have in common, you just multiply them together, and that's the greatest common factor. Why don't you pause the CD and see if you can figure that one out, and turn it back on and check your answer. I'm just going to do a factor tree on both of these. You can do a divisibility test or a factor tree. It doesn't matter. Either way. Actually, I think what I'll do is do divisibility on these. Look at 84. Think about that. You know it's even, but add those digits together. 8 and 4 is 12, so you know that 3 is going to be a factor because 12 is divisible by 3. Let's just do 3 into 84. 3 goes into 8 2 times. You're left with 24. 3 goes into 24 exactly 8 times. So now you have 28 left, which would be 7 times 4, or 2 times 2 times 7. So we can do 2 times 2 times 3 times 7. That's what 84's prime factorization is. Now let's do 360. Let's just break that using the factor tree method. I mean, it doesn't matter which one we use, divisibility or a factor tree, right? As long as we get our prime factorization correct, that's what matters. Now we'll have a 10 times 36, which we could break into a 2 times 5, and we're done there. 36 is 6 times 6, so that's what, 2 times 3 times 2 times 3? And now we have our prime factorization there. Let's just write it over next to the other prime factorization. We have 3 2's, 2 times 2 times 2 times 3 times 3 times 5. Now what we have to do is find all the prime factors that they have in common. 1, 2 2's, and then a set of 3's. Now we just multiply 2 times 2 times 3, or 4 times 3 is 12, and there is our greatest common factor between those two numbers. It's 12. Now if we had this fraction, what would it reduce to? We'll just look at what's left. 7 over 2 times 3 times 5 is 30. 7 over 30 is the reduced form of that. All of the prime factors that the two or more numbers have in common, that's your greatest common factor. You just multiply them together to get the greatest common factor. Now let's do some arithmetic operations where we need to reduce before we do our multiplication. Now think of something that we learned way back at the beginning about the associative property, and think about what we do when we multiply fractions. We multiply the numerators together and we multiply the denominators together. Remember, not the associative but the commutative property says that the order in multiplication does not matter. This problem, therefore, couldn't we change this around to 3 times 5 over 9 times 4? Because the order of the values in the numerator and denominator doesn't matter, does it? If you do that, you can clearly see that there's something you can reduce there. 3 over 9. The greatest common factor between those two numbers is a 3, which means that we could reduce those to 1 over 9 divided by 3 is 3. 1 over 3. You have to just remember that commutative property. Order does not matter in multiplication. And you can rearrange the factors, and that will help you to more clearly see that you may or may not have a greatest common factor that you can reduce. But if you see that, if you recognize something that might work, then just move them around and rewrite it, and then you can clearly see what to do. Now we just do how we always do when we multiply fractions. 1 times 5 is 5 over 3 times 4 is 12. 5/12 is the answer. And maybe you notice, like in practice problem C, that's kind of a pain to find the greatest common factor between two really large numbers like that. So on these fractions, if you reduce them first, then you won't have anything to reduce later, and it won't be quite as confusing because you won't have this real big number to work with. You'll have a smaller one that's easier to figure out how to reduce. Look at this problem. 3/14 times 7/12 times 1/5. See if you can reduce that before you multiply. Now, let's not switch everything around. That just kind of wastes time. Recognize that you have a 7 in the numerator and a 14, so you have a greatest common factor there of 7. That would make this a 1 and this a 2. Then just recognize the 3 over 12. There's a greatest common factor of 3. So this would end up as a 1, and this would be a 12 over 3, which is 4. Now go ahead and just do your multiplication. You'll have 1 times 1 times 1 in the numerator over 2 times 4 times 5, which would be 40. Now, if we had not reduced first on this problem, we would have ended up with 21 over 840. And that would have been a whole lot more complicated to just look at and say, oh, I can reduce something. You may have struggled with that or gotten it wrong. It's a whole lot easier to do it before you do the multiplications. A whole lot more easier to reduce the fractions first, then multiply them together. Look at this fraction or set of fractions. Let's reduce first, and let's just go ahead and look at that, see some things that you might recognize. A 9, do you see anything in the denominator that you could factor out? Well, you have a 30, that would work. The 18, you could factor out from that too. So you just kind of have to pick one. I'm going to do the one that looks like it'll reduce more, 9 over 18, because our greatest common factor there is 9, and so we'll end up with just a 1 over 2. And then I see a 22 in the numerator over 11. That would reduce to 2 over 1. Then we're left with a 5 over 30, which we could also reduce to 1 over 30 divided by 5 is 6. So now we have a 1, a 2, and a 1 in the numerator, which would give us a 2. And then we have a 1, a 6, and a 2 in the denominator, which would give us a 12. Now we're still not reduced, are we? We can reduce that number that we rewrite. We should have canceled the 2 and the 2 or simplified the 2 over the 6, because this has a common factor of 2, and then we just get 1/6 for our answer. Anytime we have an even number in the numerator and the denominator, that's a dead giveaway that we don't have it reduced all the way. So that's something that you should look at and just ask yourself, are my numerator and denominator even? If they are, then that's a real good sign that you still need to reduce. And so that one would have equaled 990 over 5940 if we had not reduced first. And that just would have been a lot to deal with to try to reduce that to lowest terms. So just make sure you do that. Reduce each fraction first, then do your multiplication. Now in this problem, I want you to factor it first. So break it into factors. In particular, do prime factoring on it, and then do your multiplication. Well, cancel it, reduce it, of course, and then do your multiplication. So let's just do that. 25 times 27, just look at that numerator. 25 is 5 times 5. 27 would be 9 times 3 or 3 times 3 times 3. So remember, order does not matter when you're multiplying things together. So we can just put the 3's first and the 2 5's second. And then in the denominator, we have a 36 and a 50. Those are a little bit more complicated. 50, that would be 2 times 25, or 2 times 5 times 5. And then we have the 36, which is 9 times 4, or 2 times 2 times 3 times 3. Now, let's just go back and cancel all of the common factors. We have a 5 and a 5, another 5 and a 5, a 3 and a 3, and a 3 and a 3, and that's it. Now let's go ahead and multiply out. In the numerator, we just have a 3 left, so we have 3 up there, then 2 times 2 times 2 is 8. 3/8 is the result. Now we didn't have to do prime factorization on that. It just kind of helped because the numbers were a little bit bigger than we're used to dealing with. By doing prime factorization, that guaranteed that we reduced it to its lowest terms the first time through. That's the best way to do these fractions, to reduce them down, is just reduce it as much as you can the first time through. And if you can do that, that will eliminate some chances for error later, because you just might forget. You might just write the answer down and just keep going to the next problem and not notice, oh, that one's not reduced all the way. Okay, well, that's all for lesson 24.